Unified School District freshmen are planning to attend a four-year university. He's hoping that the true proportion is at least 80%. Oops, pardon me. He takes a simple random sample of 250 San Diego Unified School District freshmen and finds that 182 plan on attending a four-year university. So what I know right now is that my p-hat is 182 out of 250. And just for the record, that is 0.728. So then the question is, he wants it to be 80%, and he gets 73%. So, is 73% just because of random variability? Sometimes you get a low sample, sometimes you get a high sample. You know, is the next one gonna be 90? You know, who knows? So the question is it just because of random variability, or is it because 80% is not actually accurate? Okay. So my goal is to find the probability that the actual sample would contain 182 or less. I'll explain why it has to be or less, who plan on attending a four-year university if the actual proportion of San Diego Unified School District freshmen who are planning to attend a four-year university is 80%. Okay? That's the question. Find the probability of getting that if 80% is the true population parameter. So, here's what you should have. First thing you should always do is state what you're trying to do. State, plan, do, conclude sort of thing. So back to stating. I'm trying to find P, which is equal to the true proportion of San Diego Unified School District freshmen who plan on attending a four-year university. Okay? That's what I'm trying to estimate. So, state the distribution and verify the conditions. What I'm hoping is that this is a normal distribution, like I talked about a minute ago, with a mean of P, standard deviation, P times 1 minus P over N, right? The only way that's going to be true is if it meets the conditions. So what are my conditions? Number one, I have to have an unbiased estimator. So it already tells me, so I would say something like a verbal sentence. The problem states that an SRS was used. Therefore, we know that it's an unbiased estimator. So it's actually measuring the correct proportion that I want it to. He got an alphabetized list of every single freshman in the district, used some type of computer generation to randomly select 250 of them, contacted all 250 of them, and came up with that proportion. Okay, so we know that it was properly done, unbiased. That means that the mean should be correct. That's the idea. Second condition should have some type of a statement about the 10% rule. So it would be a statement like, it is reasonable to assume that a large school district has at least 10 times 250, which is 2,500 freshmen. Okay. That's very reasonable. We have over 500 here at Scripps, and there's certainly more than 5 schools that would have that in our district. So it's reasonable to assume that you're making that kind of a statement. And then the third condition is your N times P. So I want to see N times P, 250 times 0.8 equals 200. I want to see those numbers on your page. N times 1 minus P is 250 times 0.2 is 50, and these are both greater than or equal to 10. So therefore, we can use the normal approximation. Okay? So we know what we're using. We know that the conditions are met. So now you need to sketch. Every time, I've been saying this all year long, every time your problem has to do with a normal distribution, you're going to sketch the normal distribution. So my distribution is a normal distribution. The mean is 0.8. Standard deviation is 0.8 times 0.2 over 250. which is approximately 0.0253, because I've done this 3 times today. Or this is the 3rd time. Okay, so I'm going to sketch a normal distribution. Single peaked, bell-shaped, cement. That's actually a pretty darn good one. Wow. All right, we're going to label the mean at 0.8. We're going to find an approximate standard deviation and mark those off here. Let's see. Obviously, if I'm going to add 0.0, this is going to be 0.8253. I'm really concerned about the less than, so let me fill those in. Let's see, standard deviation 0.8 times 0.2 divided by 250, and 0.8 minus that. This one's 0.7747. I do that again. This is 0.7494. Oops, hard to read. One more time. This one is 0.7241. Okay, so earlier, not only do you, well, first of all, not only do you draw your normal distribution, you shade the part that you're looking for. So earlier I said 73% doesn't seem that far from 80%. Maybe it's okay. Now based on this distribution, 73%, which is my p hat, is way down here. So that's almost all the way down here, 0.728. So the reason why I'm checking for that value or less is because if it's higher, that's good. I'm worried about it being less than 80%. So I'm looking for everything more extreme than the sample that I got. So this is a pretty small little area. So that's why the question says find the probability that you would get that. That's that area right there. Now how do you get the actual area? That's where you show me your work. Your work will look something like this. Let's see, I'm trying to find the probability of getting a p hat less than or equal to 0.728, right? That is equivalent, because it's a normal distribution, to a z-score of 0.728 minus 0.8 over 0.0253. All these numbers should look familiar. I'm going to figure out what that z-score is on my calculator. 0.728 minus 0.8 divided by negative 0.285. So we are almost 3 standard deviations below the mean. Okay, and then I would use the table in the back of the book or my calculator, normal CDF, from some very small number to that answer is 0.0022. Whoa, that's low. Stop that. So what it's saying is if this is the correct distribution, this is what it would look like. So the probability of me getting this sample or worse just by random chance is only like less than 0.25%. So could it happen? Sure. 22 times out of every 10,000, you would expect that to happen. But do I believe that's what's happening? Probably not. What I believe is that 80% is not accurate. The real proportion is probably something closer to my sample. I don't know what the real proportion is. I'm not trying to find the real proportion. That's not the purpose of this question. This question is just to say, wow, that's not very likely by chance. So there has to be something else working in the background, is what this question is saying. So you need to write a conclusion in the context of the problem that answers the actual question. So your conclusion will look something like this. If the true proportion for, can't spell, I do. Because I'm writing it and you're about to take a picture of it, so I'm gonna look like an illiterate teacher if it's wrong. Okay, so if the true proportion of SDSUS freshmen who plan on attending a four-year university is 80%, then the probability of a simple random sample of 100 or 0.728 or less is only 0.0022. That's all this question's asking me to do. Find the probability. I found it. I explained it in the context of the problem. In chapter, I can't remember whether it's chapter 8 or chapter 9, we're going to add on to that and we're going to say